Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Washington, researchers have created a superconducting material at both a temperature and pressure low enough for practical applications. In a paper in the journal Nature, the researchers from University of Rochester, U.S., describe a nitrogen-doped lutetium hydride, NDLH, that exhibits superconductivity at 69 degrees Fahrenheit, or 26 degrees Celsius, and 10 kilobars, or 145,000 pounds per square inch, or psi, of pressure. Although 145,000 psi might still seem extraordinarily high, pressure at sea level is about 15 psi, or 1 bar. Strain engineering techniques routinely used in chip manufacturing, for example, incorporate materials held together by internal chemical pressures that are even higher, the study said. With this material, the dawn of ambient superconductivity and applied technologies has arrived, according to a team led by Ranga Dias, an assistant professor of mechanical engineering and of physics. Scientists have been pursuing this breakthrough in condensed matter physics for more than a century. Superconducting materials have two key properties: electrical resistance vanishes, and the magnetic fields that are expelled pass around the superconducting material. Such materials could enable 1. Power grids that transmit electricity without the loss of up to 200 million megawatt-hours, MWH, of the energy that now occurs due to resistance in the wires. 2. Frictionless, levitating high-speed trains. 3. More affordable medical imaging and scanning techniques such as MRI and magnetocardiography. 4. Faster, more efficient electronics for digital logic and memory device technology. Given the importance of the new discovery, Dias and his team went to unusual lengths to document their research and head off criticism that developed in the wake of the previous Nature paper, which led to a retraction. That previous paper has been resubmitted to Nature with new data that validates the earlier work, according to Dias. The new data was collected outside the lab, at the Argonne and Brookhaven National Laboratories, U.S., in front of an audience of scientists who saw the superconducting transition live. A similar approach has been taken with the new paper. Everyone in the group was involved in doing the experiments, Dias says. It was truly a collective effort. Hydrides created by combining rare earth metals with hydrogen, then adding nitrogen or carbon, have provided researchers a tantalizing, working recipe for creating superconducting materials in recent years. In technical terms, rare earth metal hydrides form clathrate-like cage structures, where the rare earth metal ions act as carrier donors, providing sufficient electrons that would enhance the dissociation of the H2 molecules. Nitrogen and carbon help stabilize materials. Bottom line, less pressure is required for superconductivity to occur. In addition to yttrium, researchers have used other rare earth metals. However, the resulting compounds become superconductive at temperatures or pressures that are still not practical for applications. So, this time, Dias looked elsewhere along the periodic table. Lutetium looked like a good candidate to try, said Dias. It has highly localized fully filled 14 electrons in its f orbital configuration that suppress the phonon, a quantum of acoustic energy, softening and provide enhancement to the electron-phonon coupling needed for superconductivity to take place at ambient temperatures, he said. The key question was, how are we going to stabilize this to lower the required pressure? And that's where nitrogen came into the picture, said Diaz. Nitrogen, like carbon, has a rigid atomic structure that can be used to create a more stable, cage-like lattice within a material, and it hardens the low-frequency optical phonons, according to Diaz. This structure provides the stability for superconductivity to occur at lower pressure, the study said. Diaz's team created a gas mixture of 99% hydrogen and 1% nitrogen, placed it in a reaction chamber with a pure sample of lutetium, and let the components react for 2 to 3 days at 392 degrees Fahrenheit, or 200 degrees Celsius. The resulting lutetium-nitrogen-hydrogen compound was initially a lustrous bluish color, the paper states. When the compound was then compressed in a diamond anvil cell, a startling visual transformation occurred, from blue to pink at the onset of superconductivity, and then to a bright red non-superconducting metallic state, the study said. It was a very bright red, Diaz said. I was shocked to see colors of this intensity. We humorously suggested a code name for the material at this state, red matter, after a material that Spock created in the popular 2009 Star Trek movie. The code name stuck. The 145,000 psi of pressure required to induce superconductivity is nearly 2 orders of magnitude lower than the previous low pressure created in Diaz's lab. Thanks for watching. Please subscribe my channel for more videos.